Hey folks, welcome. In this section of the course, we're going to talk about the configuration management tool known as Opsworks. So in the DevOps doctrine, let's click on Application Deployments with Opsworks. AWS OpsWorks is a configuration management service that provides managed instances of Chef and Puppet. Chef and Puppet are automation platforms that allow you to use code to automate the configuration of your servers. Opsworks lets you use Chef and Puppet to automate how servers are configured, deployed, and managed across your Amazon EC2 instances or on-premises compute environment. Now, Opsworks can be seen as a platform as a service. However, unlike most platforms, you have control over the operating system, the instance count, and can make changes directly to the deployment mechanism. Now, looking at our diagram, the foundational component of Opsworks is the Opsworks Stack. And within an Opsworks Stack, you can have layers, enabling you to manage your environment at these different layers. And on the diagram is a typical stack with load balancer layer, an application server layer. Now on this layer, you would deploy your applications, PHP, Node.js, Java, whatever. You deploy your apps here. And then there's an RDS layer. So this could be a MySQL database or SQL server. So in a sense, this layering allows you to obfuscate different sections of your infrastructure and manage them separately. Let's cover a little bit more theory. Let's click on Opsworks Essentials and let's answer the question, what is Opsworks? Well, we've talked a bit about it already, but Opsworks provides a flexible way to create and manage resources for our applications as well as the applications themselves. So again, going back to that application layer, we are managing the infrastructure which makes up that layer. We're managing the EC2 instances, but we're also deploying applications to those instances. And subsequently, we can apply new versions to those applications on the instance. So we can create a stack of resources and manage those resources collectively in different layers. And we do that with Chef recipes. And Chef uses the Ruby language. And these layers can have built-in or custom recipes. So using Opsworks, we can automate our deployments, we can monitor deployments, and we can maintain deployments. Now, during the lesson, let's poke around a bit in Opsworks. So in the Management Console, I'm going to go to Opsworks, and AWS provides a brief video introducing Opsworks Stacks. And we can start fresh with a brand new stack, or we can register existing instances. So we can use existing instances with our Opsworks Stack. So some of the key features and benefits of Opsworks: support any application. Opsworks Stack supports a wide variety of architecture, from simple web apps to highly complex custom applications running on Linux or Windows. Configuration as code. This sounds familiar. It sounds like a little bit of CloudFormation. Well, it's Opsworks. It's not CloudFormation, but the same concept. Opsworks Stacks lets you define and maintain configurations for your entire environment in code and lets you provision your instances with Chef. So the Opsworks Stacks allow you to efficiently manage your applications over their lifetime, including support for automatic instance scaling and auto-healing. Stacks let you model and visualize your application using stacks, layers, and apps. Now on the DevOps Pro certification, it's good to know the components of Opsworks and the use cases for which you would use Opsworks. Now let's handle the fundamentals in this lesson, get a good handle on these components, and we'll deal with use cases a bit later in this section. The stack is the core component of Opsworks. It's basically a container for AWS resources. Going back to our diagram real quickly. So it's a container for Elastic Load Balancers, for your EC2 instances, for your RDS database. And then with layers, we modularize our stack. So we have an ELB layer, an application server layer, an RDS layer. And the layer specifies such things as the instance's settings, installed packages, and security groups. And it serves a particular purpose, like serving applications or hosting a database server. Now, the layers depend on chef recipes to handle tasks such as installing packages on instances, deploying apps, running scripts. One of the key features of Opsworks is a set of lifecycle events: setup, configure, deploy, undeploy, and shut down. So these lifecycle events automatically run a specified set of recipes at the appropriate time on each instance. So setup's going to have its default set of chef recipes. Configure the same. Deploy, undeploy, shut down. You'll run a specific set of chef recipes for a shutdown event. So basically, Opsworks handles a lot of the legwork associated with creating and maintaining applications in AWS. And with Opsworks, we can simplify the deployment pipeline and have frictionless deployments. And the easier the deployments, the more frequently we can do these deployments. Now, we've already seen some configuration management tools, CloudFormation and Elastic Beanstalk. And Opsworks kind of sits in the middle of these two. Opsworks gives us more control and customization than Elastic Beanstalk, but it's not quite as detailed and labor intensive as CloudFormation. And it does not have as much control over AWS resources. Now, one of the differences between CloudFormation and Opsworks is that Opsworks doesn't work alone. Opsworks works with Chef, which provides cookbooks and recipes to manage your stack, manage your applications. Now, when comparing Opsworks to Elastic Beanstalk, Elastic Beanstalk might be the better option for applications with short life cycles, whereas Opsworks, you have more control, but it's a little bit more labor intensive, so it's a useful tool for longer application life cycles. But still, Opsworks manages much of our configuration out of the box. There is a greater ability for customization compared to Elastic Beanstalk. When you create an application layer, let's say we're creating a PHP layer, so Opsworks with the chef recipes is going to handle a lot of the work under the hood in deploying a PHP application. Now, if the situation arises that you need to customize some of these default settings, you can write and apply your own chef recipe to do just that. And the nice thing about Opsworks is this layer structure. So again, we have modularization here, and we can work with these layers individually. All right, let's go back to Opsworks Essentials, and let's talk about Opsworks Anatomy a bit. And when we talk about Opsworks Anatomy, we're talking about stacks, layers, instances, and applications. In the management console, just following along with the lesson, I'm going to click Add Your First Stack. We'll talk about this in more detail in the next lesson, but I'm just going to I'll select a sample stack, create stack, and note the steps: creating a stack name, setting the chef cookbook repository of the stack, creating a layer, Node.js, creating a layer, assigning a recipe to deploy the lifecycle event in the layer, adding an instance to the layer. It's just important to understand the steps here. First step is to add a stack. Then a layer is added. I'll click on Explore the Sample Stack, and we'll get into more detail on this in the next lesson, but I just want to illustrate the steps. First step is to create the stack. Then you add a layer to that stack. Then you add an instance to the stack. Then you add an application to that instance. Now, where's this coming from? Well, it's coming from a code repository. It could come from Git or Subversion, wherever you store your code. So once the application is added, you can then deploy the application. And from there, it becomes monitoring. All right, now let's talk about each of these in a little bit more detail. So we have I'm going to bounce back to the diagram. All right, first we have our stack. And the stack represents a set of resources that we want to manage as a group. Elastic Load Balancer, application servers, RDS databases. Nice thing about this is we could build a stack for development, staging, production environment. And we could swap out this layer. Let's say for development, we want to save a little bit of money and we don't need as large of instances for development as we do for production. So it would just be a matter of modifying this layer to meet each of these environments: dev, staging, production. Now, of course, within our stack, we have our layers. Layers are used to represent and configure components of a stack. Now, we can use built-in layers, and we just saw that this sample stack created a layer for us. So we can use that. We can customize that, or we can create completely customized layers ourselves. All right, next we have instances. I'm going to bounce back to our documentation. Instances must be associated with one layer, but they can be associated with more than one layer. You can run instances as 24/7, they're on all the time, load-based, or time-based. Now, just explaining a little bit about the instances association with layers. Must be associated with at least one layer, but can be associated with multiple layers. So an example would be, let's say that we had an Nginx layer. Let's say we also had a PHP layer. Well, we could install Nginx and PHP on the same server. So in that situation, our instance is associated with both of those layers. As far as the 24/7 load-based or time-based, let's just go back to our auto-scaling principles, and that's all it really is. So an example use case would be we could have 24/7 instances to handle our baseline load. And then we can scale up if our load increases, or if we have predictable traffic patterns, we could scale up based on the time of day. We could scale up from 9 a.m. to 5 p.m. and scale back down after that. So this is just auto-scaling 101. Finally, we have applications. Apps are deployed to the application layer through a source code repository like Git, SVN, or even S3. So we can deploy an app against the layer and have Opsworks execute recipes to prepare instances for the application. All right, so that's our anatomy, but we keep mentioning Chef and recipes. So what are they? Well, recipes are created using the Ruby language and based off of the Chef deployment software. Now, for the DevOps Pro exam, knowing Chef and/or the Ruby language are not a necessity, but just knowing how Chef is used by Opsworks is important. We can make our own custom recipes, and we just need to specify our repository, a Git repository or Subversion or S3. Now, a group of Chef recipes is known as a cookbook, but it's the same concept. We just need to point to a repository which stores our cookbooks. Here's a key point about recipes. They're run at certain predefined events within a stack. Stack setup, you're going to have a certain set of recipes. Stack configuration, stack deployment, undeployment, shutdown. So when you shut down, you're going to want to run a certain set of Chef recipes. So when you shut down an instance, you're going to want to run a certain set of chef recipes. So just running through that again for emphasis. Setup. So the recipes occur on a new instance after the first boot. Configure occurs on all stack instances when they enter or leave the online state. Deploy. Our recipes will occur when we deploy an application. Likewise, undeploy happens when we delete an app from a set of application instances. And again, shutdown happens when we shut down an instance. So these are like built-in triggers for our specific chef recipes. All right, so that's our introductory overview of Opsworks. I'm going to go back to the main page. Now, at the DevOps Pro level, it's good to understand the differences between CloudFormation and Opsworks and Elastic Beanstalk and the use cases for each. Now, Opsworks and CloudFormation both support application modeling, deployment, configuration management. So there are certainly similarities. Opsworks and CloudFormation differ in abstraction level and areas of focus. CloudFormation allows you to provision and manage almost any AWS resource via JSON or YAML. CloudFormation focuses on providing foundational capabilities for the full breadth of AWS, but it doesn't prescribe a particular model for development and operations. So we, as the DevOps engineer, define templates and use them to provision and manage AWS resources. Now, conversely, Opsworks is a higher level service. It focuses on productivity and reliability for the DevOps engineer. So some of the structure we talked about, stacks and layers and applications, Opsworks is handling a lot of the groundwork behind the scenes that with CloudFormation, certainly you have a bit more control, but you have more work behind the scenes. So there's a trade-off. Now, one of the other trade-offs and a drawback for Opsworks is that Opsworks supports a more narrow range of AWS resources, more of a focus on the core services, EC2, RDS, EBS volumes, Elastic IP addresses, CloudWatch. Comparing Opsworks and Elastic Beanstalk, they both automate operations but serve different needs and purposes. Elastic Beanstalk is for developers who want to deploy web applications without worrying about the underlying infrastructure. Elastic Beanstalk automatically handles that deployment, the capacity provisioning, load balancing, auto-scaling. So the app will be ready to use without any infrastructure or resource configuration on the developer's part. Opsworks is going to give you a higher degree of customization and control over your operations and infrastructure. And you can use chef recipes to automate operations like software config, package installation, database setup. So to summarize, when thinking about the spectrum, Elastic Beanstalk, easier and quicker to use, less control, good for shorter life cycles. Opsworks, more control, somewhere in the middle between Elastic Beanstalk and CloudFormation. More control over your infrastructure. And of course, at the other end of the spectrum is CloudFormation, which covers a much broader range of AWS services and gives the most control. And with that, we have completed this lesson. So go ahead and mark this lesson complete, and let's move on to the next.